So in this video, I'm going to be defining the cross product of two vectors. And so the cross product is defined to be, if you're given a vector A, which has got components AXI, AYJ, plus AZK, and B vector is the X component, the Y component. We define the cross product of two vectors to be a new vector, which is also in three dimensions, to be the determinant of I, J, and K. So for example, this is, A, Y, A, Z, BX, BY, and BC. So let's do an example of this to make sure you understand the idea. So let's find the vector product of, let's assume that A is a vector to be 2i plus 3j plus 4k, and B vector is equal to 1i minus 2j plus 3k. And we're going to calculate the cross product of these two vectors. So let me do it on the top over here so I have more space. So A cross B is equal to the determinant of I 3x3 matrix IJK. It's inside this square matrix. Remember, determinants are only defined for square matrices. So 2, 3, and 4. 1 minus 2 and 3. And of course we can take any row or column for expansions, because if you know basic determinants, but we'll just for teaching, for starting you off determinants, I'm going to expand in the first row. So in that case we're expecting a sign matrix, so this will be plus minus plus, so this will be I times plus 1 times the determinant of the minor matrix. Remove this, which is 3, 4, minus 2, and 3. And let's see, I think I have enough space over here, so it should be fine. Plus j vector times minus 1, because the sign of the matrix for j is minus 1, times the minor matrix of, take out the row and column, you're left with 2, 4, 1, 2. And then finally k vector, it's the plus 1 sign. And we take out the row and column, we're left with 2, 3, 1, 2. So it's a determinant of 2, 3, 1, 2. 2, 3, 1, negative 2, I'm sorry. Getting a little lackadaisic there. So so 2 by 2, that is 3 times 3 minus 4 times negative 2 minus j times 2 times 2. Oh, I'm sorry, I just noticed that this is supposed to be a 3. So j is 2, 4, 1, 3, and I put down, so that's a mistake. Let's double check again. So I is 3, 4, minus 2, and 3. J is 2, 4, 1, 2. And K is 2, 3, 1, negative 2. Okay, good. So I just double checked to make sure everything's okay. So let's do that again. So this is now J, 3, 2 times 3 minus 4 times 1, plus a K vector. The K component is 2 times negative 2 minus 3 times 1. And so we're left with I, 9 minus negative 8, which is 9 plus 8, 17. And then a minus j, 6 minus 4, 6 minus 4 is 2, and plus a k vector of negative 4 minus 3 is negative 7. Anyway, so let's just double check. And so finally we get a vector of 17i minus 2j minus 7k. So this is the vector definition. So we're taking this definition. Now I'm not going to prove this in this video. I'll make another video for this to prove this, but we can also redefine the determinant in a different way. So this is actually the definition that I'll always start off with. But we can write this saying that we can actually prove that A cross B is exactly the same thing as taking the magnitude of A times B times the sine of the angle between them times a u vector, and this is a unit vector, perpendicular to both A and B. So my handwriting is terrible and I'm scribbling a lot. So AB, and it's a unit vector. I'll actually prove this in another video, but I don't want to get you lost in this, but we'll take this also as a definition, which I haven't proven, but I'll actually prove it in another video. Okay, so just to make sure, we're saying that this answer, 17i minus 2j minus 7k, right, is perpendicular to both A and B. So this value, whatever this value is equal to AB sine theta, meaning that if you have a vector A and you have a vector B and there's an angle theta between them, then A cross B is equal to AB, the magnitude of A, times the magnitude of B, times the sine of the angle between them, and times the unit vector that is perpendicular to both A and B. And we'll have to actually prove these statements, but I'll take this for granted right now, but I'll make another video right after this video to actually prove the statement. Anyway, and so let's just make sure. So you're saying that 17i minus 2j minus 7k is perpendicular to both A and B. So remember, this is the A vector, 2i plus 3j plus 4k. So let's confirm this to make sure we're okay. I want to keep everything the way it is, but I'll keep the last element, so I'll just write it down over here. In fact, let me write it on top. So A vector is given by 2, 3, j plus 4k. The B vector is given by 1i minus 2j plus 3k's. And we've already calculated the A cross B. So I'm going to, now one way to check if these vectors are perpendicular to each other, if you remember, so here is, let me write down A cross B before we do this. A cross B is 17i minus 2j minus 7k. So one way to check if A cross B is perpendicular, right, is we can actually do the calculation of just saying, okay, well, let's take the dot product of A cross B. And this leads to a new concept called the triple product, and I'll explain that in a separate video. But the triple product is just a replacement of ijk with a new vector. But let's not go into it right now. I'll actually try to show that. Let's calculate this. So A cross B is 2 times 17, the dot product of this vector, so we take the components, plus 3 times negative 2, 3 times negative 2, plus 4 times negative 7. So 2 times 7 is 34, plus 3 times negative 2 is negative 6. 4 times negative 7 is negative 28. Negative 28 plus negative 6 plus 28 is negative 34. So that's equal to 0. They all cancel. So A is perpendicular to, so our concept that whatever this answer is, it is a unit vector u that's perpendicular. It's got some magnitude, AB sine theta. Now, what is this AB sine theta? And if you're wondering what AB sine theta is, right, it actually represents the Ooh, not very well. But so this, if this is the B vector, so the base is B, the height is, so this is, so if this is A, the height is A sine theta, and this is B. So this is basically the area of the parallelogram that's formed when we take A and B vectors. So this area, this component right here is the area of the parallelogram of, let's write to B A vector dot 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 dot. So that's your parallelogram. So AB sine theta. So the cross product tells us the area of the parallelogram that's formed, right? Well, the magnitude. We should actually make sure that's the magnitude of the area. So let's double check also that A cross B is perpendicular to B. So repeat the process again. B dot A vector cross B. And so this is going to be 1 times 7, 17, sorry. And then minus 2 times negative 2, minus 2 times negative 2. And then 3 times negative 7, plus 3 times negative 7. So this is 17 plus 4 and minus 21. And so this is 21, 21, so that's equal to 0. So B is perpendicular to A cross B. So this is just to confirm and show you that how we calculate A cross B. Now, I put this as a definition of determinants. A lot of textbooks expand in terms of I, J, and K. They'll give you an exact definition. I want to make sure you understand how to use determinants, because in some calculations, if you know you can calculate a determinant very quickly, then you should do that procedure. For example, let me write the definition of determinant, and this is the definition I'm going to start with, but I'm going to say that this is also equal to another definition that's equal to the magnitude of AB times sine of theta times U vector, and this is a unit vector. So remember, whenever we use a hat, that's why whenever we use I hat, J hat, K hat, these are unit vectors, and this unit vector is perpendicular to A and it's perpendicular to B. So it's basically perpendicular to the plane containing A and B vector. So let me give you an example of a determinant calculation that you might want to do really quickly and know the answer to. So imagine the following. So we're told that the force field, right, for a charge Q is equal to the velocity of a charged particle in the embedded magnetic field. So if you have a charged particle traveling with velocity v in a magnetic field B and we're told charge Q, I'm going to assume that we have a charge of 1 coulomb. It's just trying to pick standard units, but really. So we are told that V vector is given by, let's say, 2I plus 3J plus 4K. And the magnetic field is, let's make it 3J in Teslas, and this is in meters per second, standard units. And I'll make this really simple, say Q is 1 coulomb. So we're actually calculating the force vector, which is the determinant of, it's QV cross B magnetic field. Q is 1 coulomb, so I'll just write 1 times the determinant of I, J, and K. And we're told that the velocity is 2, 3, and 4. And we have 0, 3, 0. So we're calculating these determinants. We could expand in terms of I, J, K, which is standard, but if you look in determinants, right, we notice that it's easier to expand the row or column with the most zeros. In this case, right, this happens to be the last row. In this case, we can write the expansion in terms of saying this is 0, or the sign matrix, plus, minus, plus. So it's a plus, minus, so we don't have to even worry about writing the zeros because we know those values. So we just have to expand 0 times the minor of this matrix, the minor matrix, 3 times the minor, and then 0 times the minor. But those two zeros are effectively zeros, so we don't have to worry about it. So we can write 3. And the sign of this is plus minus, so it's a minus in here, so minus 1 times the determinant of, take out the row and column, and you're left with I, k hat, 2, and 4. So this is minus 3 times 4i minus 2k, and that's equal to minus 12i plus 6k. So we can do the answer very quickly instead of doing an IJK expansion. So if you know a little bit of determinants. So yeah, so let's do another example just to make sure you understand the idea. So imagine that somebody's asking you, right? And I'll try to make this simple so that you understand the general procedure. So somebody gives you a vector, and let's make it really simple, 3i, and we'll do another vector of, let's say, 2i plus 2j. And so the question is, I'd like to find the area of these two vectors. So we can actually do it a couple of ways. We already know what the area is going to be. We know the area is going to be the base times the height. The height is given by 2, so we're expecting an answer of 6 units for the area. So how can I do this in terms of the cross product? Let's call this first, so this is area, not be confused. So let's call this first vector A. Let's call the second vector B. And we can use this definition AB sine theta. So we know that the area is going to be the magnitude of A cross B for the parallelogram. So in this case, that would be, actually, let me write A cross B because I don't want to put magnitudes yet. So we have a vector A. So this is I, J, and K. A is 3, 0, 0. So this is a good row to actually expand on because nobody wants to do extra calculations if they don't have to. And then the B vector is 2, 2, 0. And what's that equal to? Expanding on this second row because it's got the most zeros. Or you can actually use the last column also. Both of them will give you the same answer. So actually, let's do the last column because it looks more interesting. So let's do so let's do K, and the sign of this is a plus, so I'll put a plus 1. Determinant of the minor matrix, which is 3, 0, 2, 2. And if you look at it, this is 3 times 2, which is 6, minus 2, so 6 hat. And so the magnitude of this area, the area, is the magnitude of A cross B, which is equal to 6. So if this magnitude, right, was a vector that's got several components, you just have to use Pythagoras' theorem and find the magnitude of the vector. That's the area. So I think basically you've understood the basic understanding of a cross product, and I'll stop here. In the next video, I'll actually prove this statement that AB sine theta is equal to U and show that U is perpendicular to both A cross B generally.